Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem solve. D square y by dx square plus 3 into dy by dx plus 2y equals to x e power x sin x. So firstly, let's find the order and degree of the given differential equation. Identify the highest derivative here. D square y by dx square is the highest derivative, so order will be 2. And highest power of the highest derivative is a degree is 1. Okay, now let's write the given differential equation in operator form. Given differential equation d square y by dx square plus 3 into dy by dx plus 2y equals to x e power x sin x. We know that d is a differential operator. Then d square will be d square by dx square. Now we can write a given equation as d square y plus 3dy plus 2y equals to x e power x sin x. Now take y common from all the three terms of LHS. We'll get d square plus 3d plus 2 into y equals to x e power x sin x, which is in operator form. F of d into y equals to q, where f of d equals to d square plus 3d plus 2 and q equals to x e power x sin x. Now we need to find the general solution to the given equation or the reduced equation using y equals to yc plus yb. Here yc is a complementary function, yb is a particular integral. We will find yc using the roots of the auxiliary equation or the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. Right? Now, let's find yc and yp. We know that the auxiliary equation of homogeneous equation f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square plus 3d plus 2. Let's replace differential operator with m, so that we'll get f of m equals to m square plus 3m plus 2. Then our auxiliary equation becomes m square plus 3m plus 2 equals to 0. Now split this 3m as m plus 2m plus 2 equals to 0. Take m common from the first two terms, we'll get m times m plus 1. And take 2 common from the next two terms, we'll get 2 times m plus 1 equals to 0. If you notice, we are having m plus 2 in both the terms. So let's take m plus 2 common, m plus 1 common, then we'll get m plus 1 into m plus 2 equals to 0. Now equate each factor to 0. From m plus 1 equals to 0, we'll get m equals to minus 1. From m plus 2 equals to 0, we'll get m equals to minus 2, right? Then m equals to minus 1 and minus 2 are the roots of our auxiliary equation, which are real and distinct. So we got real and distinct roots here. Therefore, m equals to minus 1, minus 2 are the roots of f of m equals to 0, which are real and distinct, or we can call them as real and different. Okay. let's write the complementary function. We know that when two roots say m1 and m2 are real and distinct, then yc will be one constant into e power 1 root into x plus another constant into another root into x. Then what will be our complementary function? A complementary function looks like yc equals to one constant into one root into x, right? One constant into e power 1 root into x plus another constant into e power another root into x, right? Then yc will be c1 e power minus x plus c2 e power minus 2x. So we got our yc now. Let's find yp. Therefore, yc equals to c1 e power minus x plus c2 e power minus 2x. Now we are going to find yp. Right? Now, we can find yp using 1 by f of d into q. We have f of d and q, where f of d is d square plus 3d plus 2 and q is x e power x sine x. Right? So we have q x e power x sine x. That means we can just write it as some e power x into x sine x, right? Which is e power ax into some function of x form, right? E power ax into some function of x form. We are having yp 1 by f of d into q, which is of 1 by f of d into e power ax into some function of x form, right? We know that when yp is in 1 by f of d into e power ax into some function of x form, we'll shift the exponential term towards left by replacing d with d plus a, and later we'll operate the function of x with 1 by f of d plus a, right? Now, just compare e power ax or e power x with e power ax. Then for a equals to 1, we'll find d plus a, which is d plus 1. Let's shift e power x towards left by replacing this d with d plus 1. This is equals to e power x into 1 by replace d with d plus 1, okay, into x sine x is equals to e power x into 1 by expand d plus 1 whole square, will get d square plus 1 square is 1 plus 2d plus 3 into d, 3d plus 3 into 1 3 plus 2 into x sine x is equals to e power x into 1 by d square plus 2d plus 3d is plus 5d, 1 plus 3 4, 4 plus 2 6 into x sine x. Now we are having yp equals to e power x into 1 by some function of d into x into sine x, right? Is equals to e power x into 1 by d square plus 5d plus 6 into x sine x. The term under brackets is of 1 by some function of d into x into some v form. We have a formula. 1 by f of d into xv can be written as x into 1 by f of d into v minus f dash of v, that is derivative of v, f dash of d, that is derivative of d, what I am saying, derivative of f of d by f of d whole square into v. So this is a formula we are going to utilize here. Okay, since here we are having 1 by some function of d, okay, f of d. Actually we have f of d square plus 3d plus 2. Here what we mean is some function of d, 1 by some function of d into x into v can be written as x into 1 by some function of d into v minus derivative of function of d by function of d whole square into v, right? Now we are going to use this formula here. Okay, if you want, I can write this in g of d form for our convenience. Okay, fine. Now let's use this formula here. This is equals to e power x into x. Here sin x is v and this is considered as g of d, right? Function of d. So we can write this as x into 1 by function of d, that is d square plus 5d plus 6 into v minus derivative of, if g of d equals to d square plus 5d plus 6, then g dash of d will be 2d plus 5, right? So right here function of derivative of function of d by g of d whole square, that is d square plus 5d plus 6 whole square into v. We have v sin x, right? You should write sin x, not v here, sorry. Now it's clear. Okay, this is equals to e power x into 1 by d square plus 5d plus 6 into sin x minus 2d plus 5 by d square plus 5d plus 6 whole square into sin x. I just wrote the same step. Then yp becomes e power x into x into 1 by d square plus 5d plus 6 into sin x minus 2d plus 5 by d square plus 5d plus 6 whole square into sin x, right? Also we can write it as e power x into 1 by some function of d into sin x minus 2d plus 5 into 1 by some function of d whole square into sin x. Okay, so now we are going to use 1 by f of d or 1 by some function of d into sin bx form, right? This is of 1 by some function of d into sin bx form, so we are going to use this procedure here. And here also we are going to use 1 by function of d into sin bx procedure. Okay, let's go for it. For just compare b with 1, we'll get b equals to 1, right? Compare sin x with sin bx, so that we'll get b equals to 1. Then we can find d square, which is given by minus b square, which is equals to minus of 1 square is minus 1, right? Now what happens if we replace d square with this minus 1 in the denominator? We'll get minus 1 plus 5d plus 6, which is non-zero term, right? If you want. If we replace d square by minus 1, we'll get like this, right? 5d plus 5. 6 minus 1 is 5, which is a non-zero term. If we get zero term, I mean the denominator becomes 0, then 1 by 0 into sin x. We'll get the term under brackets as 1 by 0 into sin x. We know that 1 by 0 is undefined. So the total term becomes undefined. So always remember that the denominator must be non-zero. Since we got the denominator non-zero by replacing d square with minus 1. So let's replace d square by minus 1 here. And coming to this one. Here also by replacing d square with compare sin x with sin bx, and for b equals to 1 we'll get d square equals to minus 1. Likewise, if we replace d square with minus 1, we'll get minus 1 plus 5d plus 6 whole square, which is also a non-zero. So let's replace d square with minus 1 in both the terms. First term and second term. So it is not necessary to take 2d plus 5 separately from this term, okay? But for our convenience, to make a clear idea, we are just taking it outside the bracket. That's it. Is equals to e power x into 1 by, replace this d square with minus 1, we'll get minus 1 plus 5d plus 6 into sin x minus 2d plus 5 into 1 by, replace this d square with minus 1, we'll get minus 1 plus 5d plus 6 whole square into sin x, right? Is equals to e power x into 1 by 5d plus 6 minus 1 is plus 5 into sin x minus 2d plus 5 into 1 by 5d plus 5 whole square into sin x. Now let's take 5 common from these two terms. Okay, we'll get e power x into 1 by, if we take 5 common, we'll get 5 times d plus 1, right, into sin x minus of 2d plus 5 into 1 by, take 5 common from these two terms, we'll get 5 times d plus 1 whole square into sin x right, is equals to e power x into, we can split this fraction as 1 by 5 into 1 by d plus 1 into sin x, right, minus 2d plus 5 into, again we can split this fraction as, or we can just write the denominator as 5 square into d plus 1 whole square into sin x right, is equals to e power x into 1 by 5 is x by 5 into 1 by d plus 1. Here we are having 1 by d plus 1 into sin x, right? In the denominator we have d plus 1. So let's replace this plus with minus, so that we'll get d minus 1. Multiply and divide d minus 1 to this fraction, we'll get 1 by d plus 1 into d minus 1 by d plus 1 into d minus 1, whatever. 1 by d plus 1 into d minus 1 by d minus 1 into sin x minus 2d plus 5 into 1 by 5 square is 25 into d plus 1 whole square. Expand this, d square plus 1 plus 2d into sin x which is equals to e power x into x by 5 into 1 into d minus 1 is d minus 1 by d plus 1 into d minus 1 into sin x minus of 2d plus 5 into, now split this fraction as 1 by 25 into 1 by d square plus 1 plus 2d into sin x. See, this is all 1 by some function of d into sin x form, right? Again, we'll replace d square with minus 1 in the next step. This is equals to e power x into x by 5 into d minus 1 by, the denominator is of a plus b into a minus b form, so we can write it as d square minus 1 square into sin x minus 2d plus 5 into 1 by 25 into, now replace d square with minus 1. What happens if we replace d square with minus 1? Minus 1 plus 1 gets cancelled, again you will get 2d, right? Let's see what happens. I'll show you clearly. If I replace d square with minus 1 in the denominator, minus 1 plus 1 gets cancelled and I'll get 2d, which is a non-zero term, right? The denominator is non-zero by replacing d square with minus 1, so I can dare to replace d square. If we get denominator 0, the term becomes 1 by 0 into sin x, right? Since 1 by 0 is undefined, so total term becomes undefined. So here the denominator is non-zero by replacing d square with minus 1. So we are going to replace d square with minus 1 here into sin x. Minus 1 plus 1 gets cancelled. This becomes e power x into x by 5 into d minus 1 by d square minus 1 square is 1 into sin x minus 2d plus 5, or you can just write it as 1 by 25 into 2d plus 5 into 1 by 2d into sin x. So here d square appears in the denominator, so what we have to do, we have to replace d square with minus 1. Because by replacing d square with minus 1 in the denominator, we'll get minus 1, which is minus 2, a non-zero number, right? So we'll replace d square with minus 1 in the first term, in the denominator of first term, I can say. We'll get x by 5 into d minus 1 by minus 1 into sin x minus 1 by 25 into 2d plus 5 into 1 by 2d. You can split it as 1 by 2 into 1 by d into sin x, right? Is equals to e power x into x by 5 into d minus 1 by minus 1 is minus 2 into sin x minus 1 by 25 into 1 by 2 into 2d plus 5, or instead of splitting 1 by 2d like this, we can just merge these two, just like 2d plus 5 by 2d. Okay, better, we can make it easy. Is equals to, in the numerator you are having two terms and in the denominator you are having one term, so we can split this into two terms, 2d by 2d plus 5 by 2d into sin x. 2d gets cancelled and you'll get 1 here. This is equals to e power x into x by 5 into, again we can split this as 1 by minus 2 into d minus 1 into sin x minus 1 by 25 into 1 plus I'll write it as 5/2 into 1/d into sin x. This becomes e power x into x by 5 into, we can write 1 by minus 2 as minus 1/2 into d sin x minus 1 into sin x is sin x minus 1/25 into 1 into sin x is sin x plus 5/2 into 1/d sin x. We know that 1/d is integral operator and d is differential operator. This becomes e power x into minus 1 is minus x by 5 2s are 10 into replace d with d by dx sin x minus sin x minus 1/25 into sin x plus 5/2 into, we know that 1/d is integral operator, will have integral sin x dx here. Now we need to find derivative of sin x with respect to x and integral sin x dx is equals to e power x into minus x by 10 into derivative of sin x with respect to x is cos x minus sin x minus 1/25 into sin x plus 5/2 into integral sin x dx is minus cos x. Right? This is equals to e power x into, now I'll take this minus inside the brackets, then I'll get x by 10 into minus into plus minus cos x minus into minus plus sin x, right, minus 1/25 into sin x plus into minus minus 5/2 cos x. Now we can write this as e power x into x by 10 into, I'll write the term involving positive sign. I'll get sin x minus cos x. Okay, firstly term involving plus sign and next term involving minus sign. Minus into plus minus 1/25 sin x minus into minus plus 1/25 into 5/2 into cos x. 5 1s are 5 5s are. Then yp becomes e power x into x by 10 into sin x minus cos x minus 1/25 sin x plus 1 by 5 2s are 10 cos x. Therefore, yp equals to e power x into x by 10 into sin x minus cos x minus 1/25 sin x plus 1/10 cos x. We got yp and yc, so let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have c1 e power minus x plus c2 e power minus 2x plus yp e power x into x by 10 into sin x minus cos x minus 25, 1/25 into sin x plus 1/10 into cos x. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.